Hello and welcome everybody to another episode of Books in Bytes. Today we're diving deep into Johannes Kepler's Astronomia Nova,
Uh,
a book that truly lives up to its name, New Astronomy.
yeah, it really does. This book isn't just about stars and planets. It's like a journey of discovery, a scientific thriller almost,
Hmm.
where Kepler's grappling with these long-held beliefs and wrestling with complex data, and ultimately revolutionizes our understanding of the universe.
Okay, so before we get lost in space here, can you give us a quick overview of the book's main themes? Like what's the cosmic elevator pitch, so to speak?
So imagine trying to solve a giant puzzle,
Hmm.
but the pieces don't quite fit. That's Kepler's challenge. He's trying to understand the motion of Mars and the old model, the idea of planets moving in these perfect circles around the Earth. It just isn't working. So through meticulous observation, mathematical genius, and just sheer stubbornness, he tears down that old model and builds a new one based on elliptical orbits and this mysterious force emanating from the sun.
So he's like the ultimate cosmic detective. And what's fascinating is that Kepler actually takes us along on his investigation.
Exactly. Astronomia Nova isn't just a presentation of his final conclusions. It's like a chronicle of his struggles, his false starts, and his moments of brilliant insight. We see him wrestling with the data, debating with himself, and ultimately arriving at these groundbreaking discoveries.
Wow, that sounds so much more exciting than a dry astronomy textbook. So let's embark on this journey with Kepler. Where do we begin?
Well, Kepler starts by tackling the motion of Mars. You see, he inherited this treasure trove of incredibly precise observations from Tycho Brahe, his predecessor.
So Mars is like the troublemaker, this celestial rebel throwing a wrench in the works.
Precisely. Mars's orbit was slightly off, just enough to drive Kepler crazy. Imagine being a scientist and seeing these tiny discrepancies, these 8 minutes of arc, as Kepler calls them. You could ignore them, pretend they don't exist. But Kepler couldn't. He knew they held the key to a deeper truth.
Okay, so Mars is acting up. Kepler is determined to figure out why. And he's armed with Brahe's data. What happens next?
This is where things get really interesting. Kepler spends years meticulously analyzing this data, trying different geometric models, exploring these complex calculations. He even tries a model with an equant, a point offset from the center of the orbit. That had been used by astronomers for centuries. But it doesn't quite work. The data still doesn't fit.
So he's hitting a wall, trying to force the pieces of the puzzle together. I can almost feel his frustration.
And you can sense it in the book. There's this famous passage where Kepler writes, "If I had believed that we could ignore these 8 minutes, I would have patched up my hypothesis accordingly. But since it was not permissible to ignore them, those 8 minutes point the road to a complete reformation in astronomy."
Wow, that's powerful. It shows how dedicated he was to finding the truth, even if it meant throwing out centuries of accepted wisdom.
And that's exactly what he does. He abandons the idea of circular orbits, this concept that had been considered sacred in astronomy for over 1,000 years. Instead, he starts to explore other possibilities, other shapes that might better fit the data.
So he's going against the grain, challenging the very foundation of astronomy. That takes guts.
And genius. He tries ovals. He tries these shapes called conchoids. He basically throws everything but the kitchen sink at this problem. And finally, he stumbles upon a shape that fits perfectly, the ellipse.
Now, the ellipse is like the missing piece of the puzzle finally clicks into place. So that's Kepler's first law, right?
Yeah.
Planets move in ellipses, not circles.
Exactly. And this is a radical departure from everything astronomers had believed for centuries. It's a seismic shift in our understanding of the universe. But Kepler doesn't stop there. He keeps digging, keeps analyzing the data. And he makes another groundbreaking discovery. Planets don't move at a constant speed in their orbits. They speed up when they're closer to the sun and slow down when they're farther away.
That's so counterintuitive. I always imagine the planets just gliding along at a steady pace.
Right. But Kepler's second law, the law of equal areas, describes this variation in speed beautifully. Imagine a planet squeaking out an imaginary pie slice as it moves along its elliptical path. Kepler discovered that the area of that pie slice is always the same, no matter where the planet is in its orbit.
Okay, I'm trying to picture this cosmic pie slicing action. So to keep the area constant, the planet has to move faster when it's closer to the sun and slower when it's further away.
You got it. It's like a cosmic dance, with the planets speeding up and slowing down in this elegant, predictable pattern. And Kepler even goes a step further. He discovers this mathematical relationship between a planet's orbital period, the time it takes to complete one orbit, and its average distance from the sun. This is his third law, the harmonic law.
So he's not just describing these elliptical orbits, he's figuring out the math behind them, the underlying principles that govern their motion.
Exactly. He's connecting the dots,
Huh.
building this comprehensive model of planetary motion that is both elegant and incredibly accurate.
But it's not just about math and geometry, right? Kepler was also trying to understand the why behind all of this. Why do planets move in ellipses? What keeps them in orbit?
That's right. And this is where Kepler really pushes the boundaries of scientific thought. He proposes this idea of a force emanating from the sun, a force that he compares to magnetism. It's not quite gravity as we understand it today, but it's a remarkably prescient concept.
So he's envisioning the sun as this powerful force, almost like a giant magnet, influencing the motion of the planets.
Exactly. And this idea of a sun-centered force, this idea of the sun playing an active role in shaping the orbits of the planets, was a radical departure from the old geocentric view, where the Earth was the center of everything.
It's like he's shifting the entire cosmic playing field, placing the sun at center stage. This is some serious paradigm shifting stuff.
It absolutely is. And it's important to remember that Kepler was making these discoveries in a time when challenging the established order, especially in science and religion, could be dangerous.
So not only was he grappling with these complex scientific ideas, he was also navigating the social and religious norms of his time. That must have taken immense courage.
Absolutely. And it speaks to Kepler's unwavering dedication to the pursuit of truth. He was willing to risk everything to share his discoveries with the world.
Okay, so we've covered Kepler's groundbreaking laws of planetary motion, his revolutionary idea of a sun-centered force, and his incredible journey of discovery.
But there's so much more to unpack. We've only scratched the surface of Astronomia Nova.
I'm already hooked. Let's take a deeper dive into some of the more fascinating aspects of the book.
Let's do it. One thing that really sets Astronomia Nova apart is how Kepler uses math and geometry to unlock the secrets of the universe.
Yeah, the book is packed with these diagrams and calculations and geometric models. It's like a visual symphony of math and astronomy. But I gotta admit, some of it goes right over my head.
I hear ya. But that's part of what makes Kepler so fascinating. He was like a master of taking these complex concepts and making them, well, if not exactly simple, at least understandable. And his diagrams are key to that.
So he's kind of like the original infographic king, using visuals to explain these mind-blowing ideas.
Exactly. For example, he has this famous diagram showing Mars's elliptical orbit. He meticulously plots all of Brahe's observations, showing how they deviate from a perfect circle. And then, boom, he draws the ellipse. It just fits perfectly. You can almost feel the excitement leaping off the page.
It's like those mind-blown gifts. You see the pieces come together, and suddenly the universe makes a little more sense. But Kepler's more than just a math whiz, right? He's got this philosophical side, too.
Absolutely. He's constantly reflecting on the nature of the universe, the role of God in creation, and the harmony of the cosmos. In fact, he even uses music as a metaphor for planetary motion, talking about the music of the spheres.
Wait, the music of the spheres, like planets making actual sounds as they move?
Not exactly like audible sounds, but a kind of mathematical harmony. Kepler believed that the distances and speeds of the planets were related in a way that could be expressed through these musical ratios. It's this beautiful blend of science and philosophy that makes Astronomia Nova so unique.
So he's seeing the universe as this grand harmonious system,
Yeah.
governed by these mathematical laws, and he's using every tool at his disposal. Math, geometry, even music. To try and understand it, it's pretty inspiring, actually.
It really is. And you can sense Kepler's own awe and wonder as he makes these discoveries. For example, when he finally cracks the mystery of Mars's orbit and discovers the ellipse, he writes, "I felt as though I had been awakened from a sleep."
Wow. Talk about an aha moment. It's like he's been wandering through a maze and suddenly the way out is clear.
And it's not just about the scientific breakthrough, it's about the emotional impact of that breakthrough, the sense of wonder, the thrill of discovery, the realization that he's glimpsed this deeper truth about the universe. It's what makes Kepler such a compelling figure even centuries later.
Okay, so we've got Kepler, the brilliant mathematician, and the awestruck philosopher all rolled into one. But Astronomia Nova is also a story about the process of science itself.
Exactly. It's not just about the destination. It's about the messy, sometimes frustrating journey. Kepler doesn't shy away from his mistakes, his dead ends, his moments of doubt. In fact, he embraces them. He sees them as essential parts of the process, the path that leads to true understanding.
So it's a reminder that science isn't always about being right. It's about being willing to be wrong, to learn from your mistakes, and to keep asking questions.
And that's a powerful message, not just for scientists, but for anyone who's ever tried to solve a problem, learn something new, or simply figure out how things work. Astronomia Nova is a testament to the human spirit of inquiry, the relentless drive to explore, understand, and make sense of the world around us.
It makes you realize that these scientific giants, these figures who seem so larger than life, were also human beings who struggled, doubted, and ultimately triumphed through their passion and perseverance.
Absolutely. And Kepler's story is a powerful reminder that the pursuit of knowledge is a journey, not a destination. It's a journey filled with challenges, setbacks, and moments of brilliant insight. And it's a journey that we can all embark on, no matter our background or expertise.
So how does Kepler wrap up this epic journey in Astronomia Nova? What's his grand finale?
Well, after meticulously laying out his 3 laws of planetary motion, he takes a step back and reflects on their broader significance. He sees his discoveries as not just a description of planetary motion, but as evidence of this deeper order and harmony in the universe.
As we've been talking about Kepler and Astronomia Nova, I keep coming back to this idea of him being like a bridge between the old and the new.
Yeah, that's a great way to put it. He's standing at this pivotal point in history,
Yeah.
where like the ancient view of the cosmos is starting to crumble, and this new understanding based on observation and mathematical reasoning is beginning to emerge.
Yeah, he's not completely breaking from the past, though. He's still deeply influenced by the ancient Greek philosophers,
Yeah,
especially Plato and Aristotle.
absolutely. Kepler was steeped in this classical learning, and he saw his work as building upon the foundations laid by the Greeks. He even tried to incorporate some of their ideas, like the concept of perfect circular motion, into his own models.
But he wasn't afraid to break with tradition when the evidence demanded it.
Right. He was willing to abandon those cherished ideas when he realized they didn't fit the data. And that's what makes him such a revolutionary figure. He's not just refining the old models, he's creating something entirely new.
And in doing so, he's paving the way for a scientific revolution, for a new way of understanding the universe, based on observation, experimentation, and mathematical reasoning.
Exactly. Kepler's work is a crucial step in that transition, from a geocentric to a heliocentric worldview, from a universe centered on the Earth to a universe centered on the Sun. And it's a transition that has these profound implications, not just for science, but for our understanding of our place in the cosmos.
It's mind-blowing to think that Kepler was making these discoveries over 400 years ago. His ideas were so far ahead of their time, yet they laid the groundwork for so much of modern astronomy and physics.
It's a testament to the power of human curiosity, this relentless drive to understand the world around us. And it's a reminder that even in the face of these seemingly insurmountable obstacles, even when challenging these long-held beliefs, the pursuit of knowledge can lead to these extraordinary breakthroughs.
So as we wrap up our deep dive into Astronomia Nova, what's the one key takeaway you'd like listeners to ponder? What's the essence of Kepler's legacy?
I think it's this idea that the universe is not a random, chaotic place, but a system governed by laws that we can understand through observation and reason. Kepler, with his meticulous observations, his brilliant mathematical insights, and his unwavering dedication to the truth, showed us that the cosmos is not beyond our grasp. It's a place we can explore, understand, and, in a sense, predict.
And that's an incredibly empowering thought. It means that we're not just passive observers in this vast universe. We're active participants, capable of unraveling its mysteries and using that knowledge to shape our understanding of our place within it.
Exactly. Kepler's legacy is a call to action, an invitation to embrace the scientific method, to question our assumptions, to be open to new ideas, and to never stop exploring the wonders of the cosmos.
So for anyone listening who's been inspired by Kepler's story, who's intrigued by the mysteries of the universe, I encourage you to keep exploring, keep asking questions, and keep looking up at the stars with a sense of wonder and curiosity.
Because the universe is full of secrets waiting to be discovered. And who knows? Maybe you'll be the one to make the next groundbreaking discovery, to unravel the next layer of the cosmic puzzle. After all, Kepler showed us that it's possible, even when the odds seem stacked against you.
And on that note of cosmic inspiration, we'll wrap up this deep dive into Astronomia Nova. Thanks for joining us on this incredible journey through the mind of one of history's greatest scientific visionaries.
It's been a pleasure. Until next time, keep exploring, keep questioning, keep reaching for the stars.